Okay, today we are going to introduce a little bit of optimization, looking at a couple of simple problems. So our goal is to understand how to use the derivative method to solve optimization problems. Let's have a little look at what we're looking at. So the optimization problem method is 5 simple steps. Step 1 is to find the equation and eliminate all but one variable so we can differentiate. Then we differentiate. Once we've differentiated, we want to find the stationary points, the maximum, the minimum, and so on. We do this by setting the derivative equal to 0, because on a turning point, like a maximum, the derivative is going to be rising, 0, and then falling. So we can find where it's 0 is going to let us find that point. Fourthly, we want to investigate the nature of the stationary points using a sign table. On this course, we don't often do this particular step very much. Sometimes we have other questions where we reason why it's a maximum or minimum, as we saw last week, where we look at what is the sign. Is it positive, 0, negative? That means it's a maximum. Is it negative, 0, positive? That means it's a minimum. And on more advanced courses, we would use the second derivative to do this and check the concavity. But on this course, often you're told which one to find, or there's a shortcut, or you can simply just graph the function and say this one's the maximum. Finally, reread the question and give your conclusions. Usually at the end, you want to just check what was it the question was asking me to find. Often you might miss a final point if you don't reread the question. So very, very simple question for us to start with. A farmer creates a rectangular pen for his pigs by the river shown using 48 meters of fencing. Write down an equation for the area A of the pen in terms of x. So this is step 1 of the method, finding the equation. So this is step 1 of the method, find the equation. This one's pretty easy. So what we've got here is we need to find what the area is. So the area is going to be equal to x times y. It's a rectangle, so it's a fairly straightforward rectangle. Now, this type of question is normally going to have a constraint that you can use in order to eliminate one variable. So at the moment, we have 2 variables. But what we're going to need is we're going to need to eliminate all but one variable. We've got an equation now, which is in terms of x and y, the length and the width, and we need to reduce that. So look in your question for some other piece of information that you're not realizing, either from the diagram or something in the wording. Look for a number that we're not using. In this case, 48. Okay, so we have 48 meters of fencing. That means that we're going to use the fencing like this. That's 48 meters. And this is going to create the fence. So it's not going to be a square. It's going to be a rectangle. Let's see how we set that up. So we can say that the perimeter of the length of fencing is 48, and that has to be made of 2x plus 1y. If we rearrange this equation, we can say that y is equal to 48 minus 2x. This is our constraint. We can insert that into the function here to eliminate one of the variables. We still have our x, but y can be replaced by 48 minus 2x. Expand the bracket for that one. It's going to make it easy for us to differentiate. We get 48x minus 2x squared. So question 1 is to find the area of the pen, and this is it. B. Now, in B, we need to find the derivative of the area with respect to the length x. So we differentiate A with respect to x. It's going to give us 48 minus 4x. That is step 2. Done. Step 3 is to find the stationary points when the derivative is equal to 0. So here in this question, we want to find the x-coordinate of the maximum, one of the stationary points, and we can do that by differentiating and then setting the derivative equal to 0. So finding where the derivative is equal to 0, dA dx equal to 0, implies that 0 is equal to 48 minus 4x, which gives x is equal to 12 meters. Reread the question in case you've messed up. Find the value of x when the area of the pen is maximized. So this is what we've done here, and we're good. So on this particular step 4, to investigate the nature of the stationary points, well, we only got one possible solution to this. It only gave us one solution. So that has to be the maximum. In this particular course, we're not asked to verify that it is a maximum. That level of analysis is not required. Okay, that's our second question. A designer is creating a digital billboard to fit beneath a decorative parabolic arch. The base of the billboard lies along the x-axis and its top must fit under the curve of the arch. The arch follows the curve f of x from 0 to 16. We can see the information there in the diagram. So this is a very common question structure for the AISL course. It's going to start off with a show that the area question, and typically question A is often the hardest part of the question. And the reason that they often have it as a show that question is if you can't do the show that on an optimization problem, you can often do the other questions anyway, because you get to use the equation given in the question. So don't worry if you can't manage to show that. Sometimes these are in paper 2 and they have 8 different sections to them. And if you can't do part A and B, you're given the equation sometimes, and then you can do the rest of the analysis that's required. So we have to show that the area is equal to this expression. So how do we do this? So let's try and analyze what the diagram is looking like a little bit. So we can vary how far across this point P is placed. This point P is placed here, and we can move that backwards and forwards by varying x. That's going to mean that x can be down at 0. We're going to get a really small rectangle. It's going to look like this, or x can be somewhere around here. We're going to get quite a tall, thin rectangle. So as x varies, the shape of this rectangle is going to change. So if this length there is x, then this distance over here is also going to be x. So we need to figure out how long is this distance here, because this is the base of the rectangle. Well, the total length is going to always be 16. We can see this in the question, that the parabolic arch is going to cross there at 16. So this length has to be 16 minus 2 lots of x. What is the height? So we need the height here in this direction. What is the height here? Well, the height here is simply given by the function f of x that we see here. I think it's given more clearly here in the question. So this length here is going to be f of x. Whatever our x is, we can put that in. So for A, we need to show that the area is this. The area of the rectangle is going to be 16 minus 2x multiplied by f of x, which is 16 minus 2x, and f of x is given up here as minus x squared over 2 plus 8x. Expanding the bracket, firstly we're going to have 16 times this is going to give us minus 16x squared over 2. Multiply numerators, multiply denominators, and then simplify after. 16 times 8x. So you can use your calculator for this one. Big numbers. Where's my calculator? So we are going to do 16 times 8. 128. Okay. So that is going to be positive plus 128x. Next, we want this one. Minus 2x times minus x squared is going to give us minus 2x cubed all over 2. And then lastly, crab claw is finished. We want minus 2 times 8 is going to give us minus 16x squared. Collect together the like terms, rearrange into standard form. So firstly, we have, let's have a look. Firstly, we've got minus, there we go. I see why I'm getting it wrong. This should be plus. We have a minus sign there and a minus sign here. So that should give us 2x cubed. That's right. Okay. Started spotting an error. So we've got 2x cubed over 2. And then we've got 2x squared terms. Sorry, let me simplify first. This is just making it difficult. Okay, so we want this one. That 2 cancels that 2. This 2 simplifies that one down to an 8. That's much better. We've got x cubed, and then we're going to have minus 8 minus 16, which is going to give minus 24x squared plus 128x, which is the answer given. With a show that question, always finish with the answer given in the question. Look at the question for how many points are included in the question. This one's 2. So think to yourself what it is that you're going to get sort of awarded points for. You're probably going to get awarded points in this type of a question for setting up a question like this one, either that one or this one, that will lead to the answer, and then showing that you're progressing through here. Tick makes more sense. So 1 point for setting up the question, the equation, 1 point showing that it's going to get to the answer. You can't go straight to the answer with this type of a question. This is typically the answer given, which must be included as you finish. Okay, B. Find the derivative of this one. So if you struggle with finding the equations for in an exam setting, make sure that there isn't a follow-on that you can do without having to actually set the equation up. So here you could just copy it from above, but we have the equation here that a of x is equal to this. So all we need to do is find the derivative. So a prime of x is going to be 3x squared minus 48x plus 128. Lastly, using this answer, find the dimensions of the billboard that will give the largest possible area. So for C, now obviously, with this question, we could just sketch the function given here. We could just sketch this on our calculator. We could sketch this function here for the area function. We sketch the area function on our calculator. We can see what the maximum area is going to be. So to get around this, a lot of the typical wording styles for the question is using your answer from part B, which means that you have to use a derivative method for this question in order to be scored for points. That requires that you set the derivative equal to 0 and solve. So we set the derivative equal to 0. We have to solve this one. Let me pull up my calculator. So the best way to solve this one is to press Menu, Algebra, Polynomial Tools, find the roots of a polynomial. It's a second degree equation. We're going to get 2 solutions. A is equal to 3. Press the tab button here, like that. Move down to the next one nice and quickly. We want negative 48, tab, and then 128. Press enter. If you get an answer looking like this, you've got an exact answer, press Control Enter and you'll get an approximation for it. So we have x is equal to 3.38, or x is equal to 12.6. One of these will be a maximum, a local maximum. The other will be a local minimum. We can often get rid of one of them quite easily using a variety of different techniques. So I'm just going to show one other thing that we can look at on this one. So we've got the area function here. We've got this area function here. What's the domain of this one? Well, the domain makes logical sense. As x gets bigger, it's going to come across here till it gets to this point. This particular line, this x here, is going to keep coming across till it gets to that. When x gets to 8, there's going to be no space left. That's because this equation here is going to be less than 0 if x is more than 8. Look at it, 16 minus 2 lots of x. Once x is equal to 8, this is going to be 0, and anything bigger than 8 is going to be negative. So this equation here is a constraint that means that x is less than 8. So I can throw this solution out by saying that x has to be less than 8. So the x coordinate has to be x is equal to 3.38. When you finish, reread the question. Let me just clear it up a little bit. Reread the question. So it says, find the dimensions of the billboard. We haven't done that. We've got the length of x, but we don't have the length of the dimensions of the billboard that's going to give us the largest area. It's not asking for what the largest area is. It's asking for the dimensions of the billboard. So we need to use the original function and find what the length is going to be. So our original function is up here in green, this one, minus x squared over 2 plus 8x. So we do that on the calculator. If I want to use this exact value there, on your calculator, you can press scroll up to this point, press scroll left, you'll be inserted here, scroll across, hold down this shift key here. Hold down this shift key here, and then scroll across here on the right, and you can select one of the two answers. Press Control C, move down, press Control V, and you've got the number there. We can paste that now. It's in the clipboard of the calculator. So we want to use the formula. I like to just put the formula in on a graphing page. So here, oops, wrong one. Add a graph page. We want this function here. I am all over the place now, completely messing up. Okay. Control divide minus x squared over 2 plus 8x, enter. Let's go back to the home screen, press variables. I'll put it in F2 now. We want to put this number in, and this is the y value. So we also need to calculate what the base of the rectangle is going to be. It's going to be 16 minus 2 lots of x. Press Control V to paste again. So this implies, so this one isn't asking for the area, it isn't asking for the x coordinate, it wants the dimensions of the rectangle, which are going to be 9, so I'll just put a D for dimensions, 9.24 multiplied by 21.3. All right, so that's the two exam style questions that we're going to have coming up in our major on optimization. I could take this question in another video. It's a little bit longer. It's a homework style question.